Hello students, I am Vikram Singh Rathod, Assistant Professor at Center for E-Governance. Today I am describe another supervised method or a algo which is used in supervised learning in machine learning. So that's why we define a logistic regression overview here, and then after its compilation I am also put an example on logistic regression in our another e-lecture. So first of all we discuss about logistic regression. Logistic regression is a fundamental classification technique. It belongs to group of linear classifier and it is somewhat similar to polynomial and linear regression. Logistic regression is fast and relatively uncomplicated, and it's convenient for you to interpret the result. Although it's essentially a method for binary classification, it can also be applied to manipulate problems. Here I am also define some prerequisites knowledge of mathematics. So we also describe here some maths prerequisites. You will need to an understanding of sigmoid function and the natural logarithm function to understanding what logistic regression is and how it works. In our next slide, the image shows the sigmoid function or S-shaped curve. So some variable x. In this graph, you saw a line that is defined as sigmoid function using a sigmoid function. Here we define some calculation of mathematics. Let us sigma and define x is equal to 1 by 1 plus expression minus x. Here we define the x as minus 10 minus 5 and x at 0 position, then 5, then 10, and the y-axis sigma x from 0 to 1.0, 0.0 to 1.0. The sigmoid function has values very close to either 0 or 1 across most of its domain. This fact makes it suitable for application in classification methods. In this image, depict the natural logarithm log x of some variables x or values of x between 0 and 1. You can show in the graph there is two lines. One is a dotted dashes line and one is a line. The draw line indicate log x and dashed line indicate log x minus 1, and the position of x is across between the lines. You can show in the graph. As x approaches 0, the natural logarithm of x drops towards negative infinity. When x is equal to 1, log x is 0. The opposite is true, log x minus 1. Note that you often find the natural logarithm denoted within in instead of log. In Python, main.log x and numpy.log x represent the natural logarithm of x. So you will follow this notation in this tutorial. Then after we discuss problem formulation. In this slide you will see a explanation for the common case of logistic regression applied to binary classification when you are implementing the logistic regression of some dependent variables y on the set of independent x. Then the symbol defined is equal to x1 dotted from x r up to xr, where the symbol is the number of predict or inputs you start with it with the known values of the predictors x जो भी x symbol and the corresponding actual response or output y I is for each observation x is equal to 1 up to x n. Our goal is to find the logistic regression function, so we define it as a symbol such that the predicted response are as close as possible to the actual response of yi for each observation x is equal to 1 from x n. Remember that the actual response can be only 1 or 0 in binary classification problems. This means that each x or xi should be close to either 0 or 1. That's why it's convenient to use the sigmoid function. Once you have a logistic regression function x bracket x, you can use it to predict the output for new and unseen input, assuming that the underlying mathematical dependence is unchanged. And what is the methodology behind it? We discussed here. The logistic regression is a linear classification. So you will use a linear function x and put the x value and is equal to x0 plus x1, then x1 plus and up to xn positions. So we called it logit. The variable sigmoid 0 or sigmoid 1 or sigmoid n x variables are the estimators of the regression coefficients, which are also called the predict weights or just coefficients. The logistic regression function sigmoid and sigmoid input is the sigmoid function of the sigmoid and bracket sigmoid colon sigmoid and then bracket sigmoid function is equal to 1 divided by 1 plus exponential or estimators. In bracket we define minus sigmoid and then sigmoid function. As such, it's often close to either 0 or 1. The function sigmoid and sigmoid bracket is often interpreted the predicted probability that the output for a given sigmoid is equal to 1. Therefore, 1 minus sigmoid, or in x the probability that the output is 0. The logistic regression determines the best predictive weights sigmoid 0, sigmoid 1 up to sigmoid n. Such the function sigmoid is as close as possible to all actual responses yi sigmoid is equal to 1 then up to xi, where sigmoid is the number of observation. The process of calculating the best weight using available observation called model training or fitting. To get the best weight to use, usually maximize the log likelihood function LLF. So for all observation sigmoid is equal to 1 up to sigmoid xn. This method is called the maximum likelihood estimation and is represented by the equation LLF is equal to sigma I, then define the y variable, then define the sigmoid indicators and plus y minus 1 minus y ith position and then log value 1 minus sigmoid functions ith, then bracket close, where you can see when yi is equal to 0, the LLF log likelihood function for the corresponding observation is equal to log 1 minus sigmoid and then the sigmoid ith value. If the sigmoid ith value is close to yi is equal to 0, then log 1 minus I sigmoid value is close to 0. This is the result you want. If sigmoid function's ith is from 0, then log 1 minus sigmoid function drop the significantly. You do not want to what result because your goal is to obtain the maximize LLF values. Similarly, when yi is equal to 1, the LLF for that observation is yi log sigmoid and then sigmoid I. If sigmoid and then sigmoid I is close to yi is equal to 1, then log sigmoid function is close to 0. If the sigmoid x or xi is from 1, then the log sigmoid functions is a large negative numbers values. There are several mathematical approaches that we calculate the best weight and corresponding to the maximum LLF values, but that's beyond the scope of this tutorial. For now, you can leave these details to the logistic regression Python libraries you will learn to use here. Once you determine the best weight of that define the function sigmoid, you can get the predict output sigmoid values for any given input for each observation sigmoid as is equal to 1 up to sigmoid n values. That predict output is 1 if sigmoid greater than 0.5 and 0 otherwise. The threshold doesn't have to be 0.5, but it usually is. You might define a lower or a higher value if that's more convenient to your situation. There's one more important relationship between sigmoid and the sigmoid function, which is that log sigmoid divided by log minus 1, then sigmoid function is equal to sigmoid dot. This equality explains why the sigmoid is logit. It implies that the sigmoid is equal to 0.5 and the sigmoid is equal to 0, and that the predict output is 1 if sigmoid greater than 0 and 0 otherwise. Then after we describe some classification performance of our logistic regression. Binary classification has 4 possible type of results. Number 1, true negative. It is basically correctly predict negative values. True positive, it predict positive ones. False negative, it predict negative zeros. False positive, it predict positive ones. You usually evaluate the performance of your classifier by comparing the actual and predict outputs and counting the correct and incorrect prediction. The most straightforward indicator of classification accuracy is the ratio of the numbers of correct prediction to the total number of prediction or observation. The other indicators of binary classification include following. The positive predicts values is the ratio of the number of the true positive to the sum of the number of true and false positive. Then after, the negative predict value is the ratio of the number of true negative to the sum of the number of true and false negatives. The sensitivity is also known as the recall or true positions rate is the ratio of the number of true positions to the number to actual positives. The speciality is also here defined. A true negative rate is the ratio of the number of true negatives values to the numbers of actual negatives. And then after, the next slide define the single variant logistic regression. In single variant logistic regression is the most straightforward case for logistic regression. There is only one independent value or a feature which is sigmoid is equal to x, and the figure institute single variable logistic regression. Here we define the two axes. One axis is 0 from to 10 and the y axis 0.0 to 1.0, and the y axis predict y as predict x value and f into x predictions values, and the x axis is define the values as per our graph defined here. Here we put some green dotted values. Those are actual response of y-ith positions, and the line regression line is px, and the dashes line is represented logit fx values in the graph. Here you have a given set of input or output such as x, y pairs represented by green circles. There are your observations. Remember that y can only be 0 or 1. For example, the leftmost green circle has the input x is equal to 0, the actual output y is equal to 0. The rightmost observation has x is equal to 9 and y is equal to 1. The logistic regression find the weight sigmoid 0 and the sigmoid 1 that corresponds to the maximum LLF. These weights define the logistic regression. X is equal to logis 0 plus sigmoid 1x, which is the dashed black line. They also define the predict probability. Sigmoid x is equal to 1 and divided by the 1 plus expression minus sigmoid value x as a variable used define here. So here is the full black line. In this case, the threshold, the sigmoid x is equal to 0.5 and the sigmoid x is equal to 0 corresponds to the value of x slightly higher than 3. The values in the limit between the inputs with the predict output 0 and 1. In our next lecture, we create a logistic regression model using some data sets. Thanks to see the video on logistic regression and subscribe our official channel CGJPR to learn machine learning or any advanced concepts of computer science. I am again thankful to you.